Stand in front of a mirror and raise your right hand. Your reflection raises its left. You've seen this your entire life, and you've probably said the same sentence everyone says, mirrors flip left and right. That feels obvious. Automatic. Undeniable. But here's the problem. Mirrors do not flip left and right. Not even a little. And once you see what they actually do, something uncomfortable happens. The room you're standing in starts to feel less solid. Directions feel less absolute. Even the idea of yourself in space begins to wobble. Because the mirror isn't showing you a backwards version of reality. It's exposing a flaw in how your brain understands space itself. Let's slow down. If mirrors really swapped left and right, then they should also swap top and bottom, right? After all, up and down are just another pair of opposite directions. But they don't. Your reflection's head is still at the top, its feet are still at the bottom. Gravity didn't reverse. The ceiling didn't become the floor. So why would the mirror flip one pair of directions but not the other? That's the first crack in the story. Now try this. Point straight at the mirror directly at your reflection's nose. That finger is moving forward toward the glass, but in the reflection, that same finger is pointing straight back at you coming out of the mirror. That's not left becoming right, that's front becoming back. And suddenly the whole illusion starts to wobble, because if the mirror isn't flipping left and right, then why does it feel like it is? Why does writing look reversed? Why does your watch switch wrists? Why does your part in your hair jump sides? The answer is not in the mirror. It's in you. Your brain is quietly performing a mental rotation every time you look at a reflection and blaming the mirror for something it never did. And that mental shortcut is about to lead us somewhere much deeper than bathroom reflections. It leads to the structure of space itself and the discovery that proves the universe at its core can tell left from right. And that should not be possible. But it is. Let's stress test your intuition. Right now, hold up both hands in front of a mirror. Don't think, just look. Your right hand is on your right side. In the mirror, the hand on the other side moves when you move your right hand. So your brain says, see, left and right flipped. But now freeze. Stop thinking about sides. Think about directions. Lift your right hand straight up. Your reflection's hand goes up too. No flip there. Move your hand straight down. Same thing. Still no flip. Now move your hand toward the mirror. Your reflection's hand moves toward you. That's strange. From your point of view, your hand moved forward. From the reflection's point of view, that same motion is backward, out of the mirror toward your face. That's not left turning into right, that's front turning into back. Here's another quick test. Write a big letter P on a piece of paper and hold it up to the mirror. It looks backward, so again your brain screams, left, right, flip. But rotate the paper 180 degrees and hold it behind your head facing backward. Now turn your whole body around and look at it directly. It looks exactly like the mirror version. Nothing about left and right changed. You changed orientation. The mirror didn't scramble directions. It simply shows what the world would look like if you were facing the opposite way along the forward-backward axis. Try one more. Wink your left eye. The reflection appears to wink its right eye. But imagine someone standing directly in front of you, face to face. If they wink their left eye, it appears on your right side. That's not a mirror trick, that's just what happens when two people face each other. The mirror isn't flipping your body like a pancake. It's placing an imaginary other you directly opposite your position in space, and your brain is mislabeling the geometry. And that tiny mislabeling is about to open a very big door. All right, time to replace the illusion with the real geometry. A mirror does not swap left and right. It does not swap up and down. A mirror flips only one direction, the direction pointing straight into it. Think of space around you as having three basic directions: left, right, up, down, and forward, backward. When you look into a mirror, left is still left, up is still up. Your reflection's right hand is still on the same side of the room as your real right hand. Nothing slid sideways across the wall. What changed is depth. If you move one step closer to the mirror, your reflection moves one step closer to you. If you lean forward, it leans forward too, but from the opposite side of the glass. Every point in your body has the same sideways and vertical position. The only thing that reverses is how far it is in front of or behind the mirror. In other words, mirrors reverse the front-back axis. So why does that look like left and right flipped? Because you're not just observing the reflection, you're imagining yourself as the reflection. And that's where the mental trick happens. Picture someone standing in front of you, face to face. If they raise their right hand, it appears on your left side, not because their hand changed sides, but because you're oriented opposite each other. That's exactly the relationship between you and your reflection. The reflection isn't you turned sideways, it's you facing the opposite direction along the forward-backward axis. To turn yourself into your mirror self in real life, you wouldn't rotate left or right like a spinning top. You'd rotate 180 degrees around a vertical line like turning to face away from the mirror. When you do that, your left and right stay attached to your body. What changes is which direction you're facing. The mirror didn't twist space sideways. It simply shows the world as if depth were reversed, like the room extends behind the glass. Your brain, however, hates thinking in terms of front and back. It prefers left and right because that's how bodies move and interact. So it quietly performs a mental rotation, turning the reflection around to face the same way you are, and in doing so it creates the illusion that left and right swapped. The mirror stayed honest, your brain did the flipping. So if the mirror is only flipping front and back, why does your brain insist it's flipping left and right? Because your brain is not built to think like a physicist. It's built to think like a body. Your brain doesn't track abstract coordinate systems floating in space. It tracks people, faces, and movements. It understands the world through the logic of social interaction, not geometry. And socially, when you see a person facing you, your brain automatically runs a simulation. It imagines turning around to become them. This is something called mental rotation. Your brain constantly rotates objects and bodies in your mind to predict how they'd look from another angle. It's how you recognize a friend from the side, or picture how furniture will fit in a room. When you see your reflection, your brain doesn't think, ah, yes, a depth-reversed optical projection. It thinks that's another person facing me. And to map that person onto yourself, your brain performs a mental half-turn. It imagines rotating you around to face the same direction as the reflection. But here's the catch. When you rotate a body around, left and right swap relative to the observer. Not because space changed, but because orientation changed. Your brain takes the reflection, rotates it to match your forward direction, and then concludes left and right must have been flipped. It's like blaming the map for a route your GPS recalculated. The mirror gave you a perfect front-back reversal. Your brain converted that into a left-right swap so it could make sense of a familiar human posture. This also explains why mirrors feel more confusing with text than with faces. Your brain doesn't mentally rotate letters as easily as bodies. So when you see reversed writing, you notice the mismatch immediately. With people, though, your brain is fluent. It rotates, aligns, and translates body positions so smoothly you never notice the trick. The illusion feels physical, but it's cognitive. The mirror is just bouncing light. The flip happens entirely inside your skull. And that realization should feel unsettling because it means you are not directly seeing reality. You are seeing a story your brain tells about it. And mirrors are one of the rare times the story doesn't quite line up with the physics underneath. Now we zoom out. Because this mirror confusion, this tiny everyday illusion, connects to one of the deepest ideas in physics, symmetry. A symmetry is something that stays the same even when you transform it. A perfect circle looks the same when you rotate it. A snowflake can look identical when flipped or turned. For a long time, physicists believed the laws of nature had a very special symmetry. Left and right didn't matter. This idea is called parity symmetry. If you filmed a physical process, say two particles colliding, and then played a mirror-reversed version of that film, the mirrored version should still obey the laws of physics. Nothing should break. Nature shouldn't care if the universe is left-handed or right-handed. That seems obvious, right? After all, space doesn't come with labels. There's no giant cosmic arrow saying, this way is left. Left and right feel like human conventions, like which side of the road we drive on. Arbitrary, replaceable. But mirrors make us confront something strange. When you see your reflection, you instinctively feel that it's reversed, not just repositioned. Even though physics says it's just a front-back swap, psychologically it feels like something deeper changed. That discomfort hints at a bigger question. Is the universe truly indifferent to left and right? Or is that just another assumption our brains made? For centuries, scientists believed symmetry ruled everything. Equations describing motion, gravity, electricity, they all worked perfectly. Whether you flipped the system in a mirror or not, it was elegant, balanced, beautiful. Nature, it seemed, didn't play favorites. And then in the 20th century, experiments began to suggest something shocking. There might be one tiny crack in that perfect symmetry, one place where the universe actually does distinguish left from right, one interaction that behaves differently in a mirror, which means the universe itself has a kind of handedness, a preference, a direction that is fundamentally different from its mirror image. And that means your mirror reflection is not just a visual curiosity. It represents a version of reality that at the deepest level may obey slightly different rules than the one you're standing in. The illusion in your bathroom is connected to a discovery so strange that when physicists first proposed it, many thought it had to be wrong. But experiments proved otherwise. And once you see how deep this goes, the idea that mirrors just flip left and right will feel almost innocent compared to what reality is actually doing. For most of scientific history, parity symmetry was treated like a law of nature. Flip left and right and physics shouldn't care. Then came a quiet, unsettling question in the 1950s. What if that assumption had never actually been tested in every case? Two physicists, Sungdao Lee and Chen-Ning Yang, looked closely at a force called the weak nuclear interaction, the force responsible for certain types of radioactive decay. They realized something shocking. No one had ever confirmed that this force obeyed mirror symmetry, so an experiment was designed. In a lab, scientists cooled atoms to extremely low temperatures and aligned their spins in a magnetic field. Then they watched how the atoms decayed, carefully measuring the direction in which tiny particles shot out. If parity symmetry held, the particles should be emitted symmetrically. The mirror version of the process should look just as valid as the original. But that's not what happened. More particles came out in one direction than the other. When they compared the setup to its mirror image, the results didn't match. The mirror version wasn't just different, it was physically wrong. The weak force, it turned out, violates parity symmetry. Nature, at a fundamental level, distinguishes left from right. This wasn't a small tweak. It was a conceptual earthquake. Up until then, physicists believed the universe didn't care about handedness. But this experiment proved that deep inside atoms, one direction is special. There is a real, measurable difference between left-handed and right-handed processes. Your mirror reflection is not just a reversed view. At the level of certain physical laws, it represents a world where at least one interaction would behave differently. It's subtle. You won't notice it brushing your teeth. But it's real. The bathroom mirror, which felt like a harmless visual trick, is connected to a crack in the symmetry of the universe itself. Your brain's confusion about left and right turns out to echo a deeper truth. Reality is not perfectly balanced. Somewhere, buried in the math of particles and forces, the universe has chosen a side. At this point, the mirror has done something unexpected. It started as a simple visual annoyance, backwards text swapped hands and ended up pointing toward a fundamental asymmetry in the laws of physics. But there's one more layer to this, because the mirror didn't just expose a quirk of the universe, it exposed a quirk in you. Every second of your life, your brain is constructing a model of reality. Not a perfect copy, a useful one. A simplified simulation that helps you move, predict, and survive. You don't see raw light patterns, you see objects, faces, directions, stable space. Your brain quietly edits the chaos of sensory data into a story that makes sense. And most of the time, that story is good enough that you never question it. But mirrors are one of the rare cases where the story and the physics drift apart. Physically, nothing about left and right changed. Light rays bounced off you, hit the mirror, and traveled straight back. The geometry is clean, precise, unambiguous. But your brain doesn't report that geometry. It reports an interpretation shaped by bodies, social experience, and mental rotation. It tells you with total confidence that left and right flipped, even though they didn't. That gap is the important part. Because it means what you experience as reality is not reality itself. It's a best guess, a controlled hallucination constrained by sensory input. Usually the hallucination lines up well with physics. In a mirror, it slips. And if your perception can be this confidently wrong about something as simple as directions in a bathroom, what else might it be simplifying, reshaping, or quietly getting wrong? Mirrors don't just reflect light, they reflect the limits of how your mind understands space. So the next time you stand in front of a mirror, pause. That person looking back at you is not a left-right flip version of yourself. They are a version of you mapped into space with one direction depth reversed. Sideways is still sideways, up is still up. Nothing slid across the wall. What changed is orientation, not identity. Your reflection is what you would look like if the world extended backward through the mirror instead of forward into the room. And yet your brain insists something more dramatic happened. It feels like a reversal, a contradiction, a subtle wrongness in the fabric of space. That feeling is the real clue, because it tells you that your sense of reality is not built from physics first. It's built from intuition, body awareness, and mental shortcuts. The mirror is a boundary between two descriptions of the same world, the clean geometry of light rays and the story your brain tells to make sense of them. And deeper down, physics itself mirrors that tension. For centuries, we believed left and right were interchangeable, perfect reflections in the laws of nature. But the universe disagreed. At the smallest scales, reality breaks that symmetry. There is a difference between a world and its mirror image. So when you look into the glass, you're not just seeing yourself. You're seeing a reminder that perception is a translation, not the original text, and that even the universe at its core is not perfectly symmetrical. The mirror didn't flip left and right. It flipped your understanding of reality.